Myself, Mrs. NJ Kotmire. I am working as assistant professor in the Department of Technology. Title of my research topic is Battery Charging System for Electric Vehicle. This is the outline of my presentation, which includes the introduction, classification of DC-DC converter, literature survey, methodology, implementation, conclusion, and references. Electric vehicle is used everywhere because of their reduced fuel usage and greenhouse gas emission. Electric vehicle are used everywhere because they give the less toxic emission. In India, fossil fuels are limited in availability. The petrol or diesel petrol or diesel vehicles, they gives the toxic emission which will affect the public health. Hence, in order to giving the less gas emitted vehicles, there is use of the electric vehicle. Electric vehicle having the low cost and high efficiency, they needs the less components. Hence, electric vehicles is used for the charging the battery of the electric vehicle. Whatever the battery used for electric vehicle, it plays an important role because it will use the efficient and reliable power for the battery. And battery charger, which is used for the electric vehicle, it must be efficient and reliable with high power density and low cost. Its operation depends on the components and control and switching strategies used in the electric vehicle. So three types of levels are used in the battery of the electric vehicles: level 1, level 2, and level 3. Level 1 and level 2, they are used for the private and public facilities, and level 3 is used for fast charging, and it is used in the public station. So level 1 and level 2, they are installed in parking lots, shopping centers, hotels, restaurants. And level 3, it is used in the public charging stations. One of the most challenging and important problems associated with the chargers of electric vehicles is charging time and battery life. So in recent years, efficient and reliable chargers with high power density and low cost and low volume have obtained increasing interest due to fast charging and less time requirements. The proposed research paper is used to analyze the battery charging system for electric vehicle. This is the energy distribution for the electric. This is energy distribution in India. In India, 75% of total vehicles are used for the transport. In transport, 14% CO2 is emitted by the electric vehicles. So this is the classification of DC-DC converter, which consists of the isolated and non-isolated DC converter. Isolated DC-DC converter having the transformer, and non-isolated DC converter having the no isolation. They use the capacitor, inductor, and diodes. Because of the use of the capacitor, diode, inductors, there is less stress on the switching, and these components give the low conduction loss. And isolated DC converter use the transformer, which will increase the weight of the isolated DC converter. These isolated DC converter having the 5 types: flyback, forward, push-pull, half-bridge, and full-bridge. And non-isolated DC converter having the buck boost and buck boost DC converter. So main concentration on the non-isolated DC converter. This is the classification of non-isolated DC converter. Reference number 16 is the design the buck converter. Reference number 17 design the buck boost converter. Reference number 18 design the boost converter. So reference number 16, they designed the buck converter with inductor, diode, and capacitor. Reference number 17 designed the buck boost converter in cascaded mode, and reference number 18, they designed the boost converter for the PV array. So from the literature survey, the buck converter used by the reference number 16, they require single inductor, single active switch, and they found the less output voltage ripple. Reference number 17, they designed the boost converter with single inductor and two active switches. They found the high output voltage ripple. And reference number 18, they designed the buck boost converter with three inductors and two active switches. They found the less output voltage ripple. From this comparison of non-isolated DC converter, it is found that buck converter is suitable for the proposed battery charging system, having the least number of components and less output voltage ripple. The main contribution of the proposed paper is to classify the DC-DC converter, to compare the non-isolated DC converter, and use of buck converter for the electric vehicle by using the machine learning based model, and also use of PID controller for getting the stable and optimizing charging process in electric vehicle. This is the application of this converter in electric vehicle system, which consists of AC supply, full wave rectifier, DC converter, battery. There is use of the controller for the DC converter. Machine learning based approach is used for the proposed battery charging system by using the buck converter. So this is the proposed closed loop buck converter. In the buck converter, the switch is controlled. That switch is controlled by a pulse width modulation technique. That is, duty cycle is controlled. Traditionally, PID controller and pulse width modulation control technique used for the buck converter, they are based on the feedback loop. So use of machine learning based for the buck converter, it will use the real-time operation, optimize the charging of the battery of the electric vehicle. This is the result analysis for the buck converter, boost converter, and buck boost converter in terms of conversion ratio, input voltage, output voltage, duty cycle, output power, switching frequency. So for buck converter, switching frequency is 82. For the boost converter, it is 15. For buck boost converter, it is 50. So from this result analysis, it is found that the buck converter is suitable for the proposed charging system. These are the advantages and disadvantages of non-isolated DC converter. Buck converter having the simple topology, they use for the step down the voltage, and it gives the less. And the output voltage cannot be increased by the buck converter. And buck boost converter used to step up or step down the voltage. And disadvantage of buck boost converter, it has complex circuit design. Boost converter also having the complex circuit design, they use to step up the voltage. This is the result analysis in terms of conversion ratios. Buck converter having the conversion ratio of M of D equal to D. Buck boost converter having the conversion ratio of minus D upon 1 minus D, and the boost converter having the conversion ratio of 1 upon 1 minus D. So buck converter is used to step down the voltage. So the buck converter is suitable for the proposed charging system. This is the result analysis for the PID controller used for the proposed charging system in terms of duty cycle. This is the output in terms of duty cycle. For the duty cycle of 0.20, for the duty cycle 0.33, for the duty cycle 0.36, and for the duty cycle 0.54. For the duty cycle 0.20, the output voltage, it varies. It gives the 20 volt. It gives the for the duty cycle 0.33, output voltage is 34 volt, and for the duty cycle 0.36, the output voltage is 54 volt, and for the duty cycle 0.54, the output voltage is 60 volt. So as the duty cycle increases, there is oscillation increases. So as the oscillation increases, it will affect the performance of the battery charging, and it will also affect the efficiency. So charger for the battery charging system, it must be efficient, and it must require the lower number of components, and it have less output voltage ripple. Hence, the buck converter is suitable for the proposed battery charging system with the machine learning based approach. And this machine learning based approach, which will improve the efficiency of the proposed charging system. These are the references I used for the proposed paper. Thank you.